Alright, so here's a few tips for getting started with the lab this week. First of all, there are two tasks that you need to do. So I suggest that you set that up as two separate projects in CodeWarrior because it's basically two different programs. So the first one is reading the input from a pin which is unconnected, a floating pin, and just displaying the value of that on an LED. So these are things that you've done before. You know how to read an input from a digital input pin, and you know how to set the value of an LED. So that's part A of the lab. Now part B involves some things that you haven't seen before. So what I'm going to do is just show you about some of setting up some of those in CodeWarrior. So the first thing that you need is pulse width modulation. And the easiest way to use pulse width modulation is through the processor expert component called PWM. And one of the things that I'll point out about this component is this setting that you need to provide, which is this initial polarity. So let me show you how this works. Basically, PWM is controlled by these two parameters. That's the initial polarity and also the ratio. And so the easiest way to read this is to look at this example where you see initial polarity low, ratio is 20%, and look at the shape of this waveform. And then compare that with this one here, initial polarity low, ratio 80%. And compare these two waveforms that you see with the different ratios and the polarity, and have a look at what voltages are actually generated. And then compare those with initial polarity high, and you see ratio 80% and ratio 20% again. So basically you need to choose the initial polarity in such a way that the ratio will correspond to the brightness of the LED. So you want 20% ratio to correspond to 20% brightness, and you have to choose the polarity according to the way that the circuit is wired. So that's the first thing to be aware of. So when you configure PWM, if you add the component into your project, the first thing that you need to do is set in the inspector, set the pins which are going to be used. So for example, we know that the red LED is on PTC3. And so we'll configure that. And next we need to specify the period that we want to use. And it's important here that the period is fast enough that the human eye will not perceive the flickering. You want this to be something pretty quick. So I'll go with 1 millisecond. You also need to specify the starting pulse width, which we can put to 0. Basically anywhere between 0 and the period can be used as the starting pulse width. And here is that initial polarity setting that I talked about just before. So that's how you would set up the first PWM component. I'm going to call that one red because it's linked to the red LED. Now let me add a second component, and I will show you this. Basically, what it's saying here is which timer module should we use. And so internally, remember that PWM on this board is implemented through this flex timer module, and there are two flex timer modules. And the first one has 8 channels, and so we can run 8 PWM pins from the same timer unit. So what we'll do is we'll reuse this existing timer module, this TU1 component. So we're reusing the existing one. By the way, you can see it here under referenced components. So this was the component that was automatically created for us in order to drive the first PWM module that we created. Now the second one, let's create that. And we need to specify output pin, which I'm going to use green PTD4. Now the period, let me give you an example here. If I set 2 milliseconds for the period and pulse width of 0, starting width of 0, then I see I get this error, which is a conflict in the required values. And the reason for that is I have 2 different PWM instances set with a different period. Remember that if these are to use the same timing source internally, the way that that system is designed needs both of them to have the same period. So I set the same period, and you notice that the error message goes away. So this one I will give the name of green. And so adding the final module, once again reusing the timer, I'm going to call this one blue, and I'm going to set it to pin PTA2. Now remember that the blue pin has this JTAG, is configured for JTAG by default, so we have to go in and turn that one off. similarly to what you would have already been doing with your bit I/O outputs. So just over here in the CPU properties, JTAG, and I'll disable TDO so that we no longer have that conflict. And then you see the error messages disappear. So that's how you would set up pulse width modulation. Now you use this component by the set ratio functions here. And so basically set ratio 8 and 16 correspond to the size of the input number that you're providing. So an 8-bit number or a 16-bit number. And basically the range there, you can read in that description, the range gets mapped onto the ratio from 0 to 100%. So have a read of that. That's how you would control the duty cycle for these components. Now for accessing the serial port, I'm going to show you a new component here which is a little bit easier to use for this purpose, and it's called console I/O. The way that console I/O works, this lets you use the printf function. And so printf, as you know, is quite a convenient function for converting integers and floating point numbers and just displaying them as strings. So doing int to string conversions and float to string conversions, that sort of thing. So the way that you set up console I/O, you add it to the project, and then inside of console I/O here in the components view, you see it's got this serial LDD component that it creates internally. And that's where you configure the UART. So here we need to select the appropriate UART pins which we want to transmit our signal on, and also supply the baud rate in here that we wish to use. So that's how you set up console I/O. Now you would use this, as I mentioned, through the printf function. So you could say hello through printf, and that will then generate and print that message out over the UART that we have configured here. Now, of course, in printf, one thing that you can do is convert integers. So let me give you an example. Let's say I have uint8 value, which is called red, and I'll initialize that one to 0. Then I can print out that value by using the %i for integer conversion and put that here in my printf command, and that will print out the value that you see written there. Now to receive characters from this console I/O, there's a function that you can use that's called getChar. And so the way that you would use this is simply fetch a value, and it just returns the char value that is provided. So this is from the C standard library. So these are functions that you would use if you're writing C programs on a computer, and they provide wrappers here that emulate that on the microprocessor. So basically, getChar, simple function, will return a char from the serial port. So this will block waiting for a character to be received. And so then you can use that character in your code to handle it however that you like. So that's a little bit of things for how you can get started with the lab this week.